We do get glacial calving, but if you look at the left side of the glacier, it's already at the far shore of the lake.
Yeah.
So probably within 2 to 3 years, there'll be no more calving icebergs.
Yeah.
Because it'll all be above the far shore of the lake. You guys have any other questions about glaciology or... So it's approximately 13 miles long. It's receding about 550 feet a year. It's losing tons and tons and tons of volume. So the area where the rocks are exposed on the left and where the rocks are exposed on the right was all glacier when I moved here in 2011. So it loses a lot of its volume and its mass, not just where it's receding. When I moved here in 2011, there was really no rock. Actually, there was no rock exposed at the terminus. Where that big rock is to the left at the terminus, that's bedrock. That was a steep, steep glacial slope when I moved here in 2011. So water, whether it's a liquid or a solid, absorbs the long wavelengths of light. Where the ice is really dense, it forms a crystalline structure. It acts like a prism. The reds and the yellows are absorbed, the long wave light, and the short wave light is allowed to pass through because that dense ice is very translucent. So it reflects back at us and we see it in the form of blue. And where the sunlight has allowed all of the ice to expand and allows oxygen to kind of be added as it decompresses, then all of the visible colors of the light spectrum are then absorbed and we see it as white. And that's glacial till material. That's the brown color or gray color or black color, and that is ground up mountain, which contains the native bedrock, which contains all that beautiful mineral that you now know is the magic dust that flows to the sea and fertilizes the sea. I'm not sure if Misha mentioned that, but so the native bedrock here is comprised of things like phosphorus, silica, and iron. And so as it's ground up in the glacial till, the lightest of which is glacial silt, and the lightest of that is called glacial flour. And it's so light it's suspended in the water column. That's why you see the glacier runoff lakes and streams being kind of a grayish hue. And that's all the beautiful silt. So that all contains the valuable minerals of the native bedrock. So it flows to the sea in the glacial outwash plain pulled down by gravity. And as it gets to the sea, it mixes with our enormous tidal exchange, up to a 25-foot tidal exchange in one day. And it changes every 6 hours, 16 to 18 feet on an average day. That tide and the whale action from the trophic cascade mix all of the water column, evenly suspending the minerals in the water column. These same rivers and streams that flow off of glaciers are the same rivers and streams that the salmon come up and spawn in when they mature. And as you already know, because you've seen them today, when they spawn, they die. So they're fertilizing the land, the watershed, and the sea. Like, they're full of carbon and they're also full of nitrogen. So we have the isotopes of salmon in all of our trees and in everything green that's around us. So it's literally a big circle of life, because the salmon are the largest naturally wild producing Pacific salmon population in the world. And they grow up so big and strong because they need really cold water, which the glacier runoff in the sea provides. And they also need hyperoxygenated water, which the tide and the ocean mixing from the whales and the runoff from all the glacial outwash plain rivers and streams adds all the oxygen. So that allows the salmon to be the biggest population. So they're then fertilizing everything for perpetuity.